Can you see my screen now?
Yes, sir.
Yes,
Yeah.
sir.
Okay. Okay. So in the last class, we looked into examples of the while loop, and also we introduced the for loop. Some examples. Okay. Mm, okay. So let me just refresh the concept of the for loop again, since Tanmay was not there yesterday. Control one. Okay. So apart from the while loop, we also have a for loop. The general form of a for loop is shown here. For followed by an iterator, and then we use the keyword in. For is a keyword, in is a keyword. Okay, we have to use an iterator in iterable. Okay, iterable is a collection of elements, and then we write colon. Also, we should leave a tab. Okay, let me remove the hash for now. And then we write the suite of statements that are supposed to execute within the for loop. Okay, so this is the general syntax of a for loop. An example is shown here. For I in range 10, print I comma end is equal to slash t. So here the iterator we have taken in this case is I. Okay, it's not, need not be always I. You can choose any name of your choice. For example, it could be num also. Okay, then I have to print num here. Then we need to understand the range function. Okay, so when we uh, open the help for the range function, help range. So what range does is it returns an object that is a sequence of integers. Okay, so there are different forms of range. Okay, so range 10, range 5 comma 10. You can provide the multiple values. Range 1 comma 10 comma 2. Okay, so this range is a built-in function. So it usually takes the general form of range is range start stop step amount or increment. Okay, so if a single value is given, okay, it treats this and always start has a default value of 0. So this is same as writing range of 0 comma 10. Even if start is not specified, it will be assumed. Okay, so let me show that also. Start is 0 by default and step is 1 by default. Okay, stop does not have a default value. So so when I say a default value, what we mean is if no value is given, then it assumes a special value called as the default value. For example, in range 10, okay, so no start value has been specified. If it is a single value, it will take the first value as 0, and then 10 as the value of stop, and also the step as 1. Okay, and it returns the elements in the range start to stop. Okay, start to stop without including the stop element. So if it is range 10, it gives us a set of integers starting from start. Since start was not specified, default it starts from 0, so it will be 0, 1, 2 up till 9, not including 10. Okay, and if a start value has been specified, then it starts from there. 5, 6, 7, 8, 9. These are the values it returns. It returns these values. Again here, the stop value is not included. Okay, 10 is not included. Fine. Okay. And in both these cases, the step value was not specified. That's why it increased these values by a step 1, 0 to 1, 1 to 2, 2 to 3, and so on. Similarly, here also 5 to 6, 6 to 7, 7 to 8, 9, and so on. But if we specify a different step value, if we give three parameters, first value will be taken as start, second value will be taken as stop, third value will be taken as stop. Okay, so it starts from the first value, start is included 1, and then after 1, okay, it counts in steps of 2 rather than steps of 1. So from 1 we have next, if I move 2 steps ahead, I go to 3, like that. 1, 3, 5, 7, 9. Okay, next is 11, but 11 exceeds stop, so it gives us the values 1, 3, 5, 7, 9. Okay, let us see an example of this in our program. Maybe this end is also optional. If I run the code, you see the range has generated 0 to 9, and num is now the iterator. Okay, it iterates. It takes one value at a time from this collection. So first time it takes 0, and action performed in the body of the loop is to print it. So it has printed 0 here. Next time, in the next iteration, num becomes 1. So we print 1, and likewise 0 to 9 it gets printed. Okay, by default the print always adds a new line at the end. If I want to change that behavior, I can specify my own end character. So I say that instead of putting a new line, put a tab as the end character. So this time, see the output after printing 0, it is printing tab, not the new line. That's why the output is not going to a new line. Okay, in a single line we get printed these values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose say I specify the range as 2 comma 10. Okay, this time, see, it starts from 2 and goes up till 9. Okay, 10 is not included. And similarly, if I write 1 comma 10 comma 2, it will print values in a step of 2 starting from 1. Okay, up till 10, not including it. So we are getting 1, 3, 5, 7, 9. Okay, this is how a for loop works. So for the for loop to work, it requires a iterable, a collection of elements through which it can run one element at a time in a sequential manner. Okay. So range is one example of an iterable, but it is not necessarily the only iterable. Okay, we can use lists, tuples, and also strings also. So I have an example here. Uh, See here, this time the iterable is a string. Again, the string is also a collection of characters. We have taken ch as the iterator. So every time ch takes one character from it. First time it takes the character d. Next time, next iteration it takes I, and so on. On this character, we are applying a function called as upper. So if the character is not uppercase, it will convert it into uppercase, or otherwise if it is already uppercase, it leaves it as such, and later it gets printed because it is within a print statement. Okay, so let's run the program. So you see all the characters are printed one at a time, D, I, S, H, A, but also in uppercase. Okay, so this is how you can use an for loop on a string as well. Okay, and you can write like how we had nested while, we can also have nested for, a for within a for. Okay, so in this program we print a matrix of zeros and ones. Okay, I give 5 as the input. I get a matrix of size 5 cross 5 where we get alternative zeros and ones. Okay, so let's try to understand this. So when num is set to 5, the loop runs for I in range 5. Okay, range 5 gives me the range as 0 to 4. So every time I takes 0, 1, 2 and so on. Within the outer for loop, we have another for loop j, which also iterates between 0 to 4, 0 including 4. Every time we add I and j. So first time, very first time, I is also 0, j is also 0. 0 plus 0 mod 2 gives me 0 itself. That's why we have a 0 printed here. After printing the value, we print a tab. Next, so here the inner loop goes for the second iteration. The first outer loop is still in its first iteration, whereas j has finished one run. Okay, so next it will go to the next value where j becomes 1. I is still 0. 0 plus 1 is 1. 1 mod 2 is 1 itself. Okay, it prints 1 and then a tab. J becomes 2. 0 plus 2 mod 2 is 0. So it prints a 0 and so on. Okay. So like that, J becomes 4. So 0 plus 4 mod 2 will be 0. It prints this last 0. After that, j becomes 5, it goes out of the range. Okay, so this for loop has finished its execution. It goes to the next statement, print. So if I don't write anything, if I write an empty print statement, it will print a new line. So after this, after printing 0 and a tab, it prints a new line here. Okay, now one iteration of the outer for loop is over. It goes to the second iteration where I becomes 1 now. Next, again it starts the inner for loop, which restarts from 0. So 1 plus 0 is 1 mod 2 is 1. So you get 1. Okay, and likewise, if we continue reasoning, you will get this alternative zeros and ones. That is how we can use nested for loops. Okay. So write this code in your IDE and let me know what is the output of this code. Can you see this code?
Yes, sir.
Yeah. So this illustrates that you can even include a while within a for, or even you can, if required, you can even write a for loop also nested within a while also. That's also possible. Okay, this program illustrates that. Tanmay, are you typing the program?
Yes, sir.
Yeah. Okay, instead of this end, you can probably type end space two space. You can even type a tab also slash d. What is the output of this program? Type only the uncommented code. Don't type the previous ones. 36, line number 36 onwards.
So we get a diagonal matrix type thing, but from
Diagonal
1 to
matrix 1 to 6. Okay, in the increasing order, right?
yes, sir.
Okay. Tanmay, finished?
So I think you have to add her in the thing again.
She again
She
went out. Hello, Tanmay.
1 second, sir. I'm almost done.
Hmm.
Done, sir.
Okay. Are you getting the same output?
Yes, sir.
Yeah. Okay. So how does it work for the first time? What is the value of I? What is the first value of I?
1.
1. Okay. I starts with 1. J also starts with 1. Okay. What about this while loop? Is the while loop condition true?
Yes, sir.
1 is less than or equal to 1, which is true. So it goes on to print the value of j. What is the value in j?
1.
1. Okay. So it has printed this value. Yeah, on the right hand side, I'm showing the output. Okay. So it prints the value 1, and then j is incremented by 1. Okay. New value of j will be how much now? After this line number 40, what will be the new value of j?
2.
2. Okay. So it checks whether 2 is less than or equal to I. I value is 1. Is 2 less than or equal to 1?
No.
False. Okay. So while loop does not go to the next iteration. Okay. Because the condition fails. After that, we have a print statement which prints a new line. Okay. Without empty print. So here, after printing 1, it comes to the next line. And next, where will the control go after executing line number 41? After print, will it finish?
We'll go to while again.
While? No. Look carefully. It goes to the second iteration of for. Okay. I will take up the next value. What is the next value of for I?
3.
2.
I is not 3. 2. I is 2. Okay. It is j that became 2. I was 1. Okay. So first value in the range was 1. It has taken that value. In the second iteration, I is 2. And j is reassigned to 1. Okay. J is no longer 2 now. Condition 1 less than or equal to 1 is j has a value 1, I has a value 2. So is j less than or equal to I? Is the condition true? Is 1 less than or equal to 3?
Yes.
The condition is true. So print the value of j. J has a value 1, so 1 gets printed. J is incremented by 1, so j becomes 2. Is 2 less than 2, less than or equal to 2? Yes, the condition is true. It prints 2. J is incremented, j becomes 3. 3 is not less than or equal to 2. Okay, condition fails. So we go to the next, it executes the print statement. Okay, so it comes to the next line. I takes up the next value in the range, which is 3. J is reset to 1. So this code again will print 1, 2, 3. When j becomes 4, it exceeds I, so it prints a new line and so on. Okay, it keeps on repeating. I takes the value starting from 1 up till 5. Okay, it doesn't take the value 6. So if I want one more line of output, 1, 2, 3, 4, 5, 6, what change should I do to the program?
Change the range.
Range to
1 to 7.
7. Okay, like that. Okay, so with this, what we are illustrating is we can write a while loop as part of a for loop. Okay, same way, maybe in a while loop, if you require, you can even also write a for loop also. That's also possible. Okay, next, write a program. Take down. Write a program to check whether a number is prime or not. Whether a entered number is prime or not. Okay, let's write a pro. Suppose I give you a number like 35. Is 35 a prime number?
No.
So why is it not a prime number?
Because it's divisible by other numbers other than 1 and the number itself.
1 and 2. Sorry, 1 and itself. Yeah. Okay. So let's try to write a program for that. Check prime.py. Okay. First, we will ask the user to enter a number. Number is equal to eval of input enter number. Okay. Now, tell me, how do we decide whether a number is prime or not in programming? We know by definition that prime number is a number which is only divisible by 1 and itself. Okay. So if I give you a number, how do you say that it is not a prime number or it is a prime number?
If I divide the number with any other number except 1 and itself, the
Ah,
remainder should not equal to 0.
remainder.
Should not be
Okay.
equal to 0.
Okay. Okay. So it gives a non-zero remainder is saying, but you are saying if I divide it by any other number than one and itself. So when I say any other number other than one and itself, then you have to test infinite number of numbers, right?
It should be between the number 1 and the number which is
Okay.
0.
Yeah. Okay. That's a better improvement. So in between these two numbers, okay, one and itself, if I find at least one number that divides this number leaving a remainder 0, then it is no longer a prime number. Suppose, for example, let's take the example of let's say 6. Okay, so what is the range in which I have to check whether it's a prime number or not? Which all numbers should I try to divide by?
1 to 5.
1, 2,
Why is one required?
1
One
to
always divides,
9,
right?
2 to
Sorry.
9.
Huh? We should start with 2. Okay, we will start with 2 uh, and then check whether it divides. Okay, if 2 what are the example I gave? 6. Okay, so but 2 is divisible by 6, so it's no longer a prime number. Okay, let's take a slightly different example. Let's take 15. Okay, we try dividing it by 2, it doesn't divide. We try dividing it by 3. 15 is divisible by 3, so we will say it's not a prime number. Okay, so what we will do is, to begin with, we will assume that it's a prime number. Okay, so I will keep a flag setting. Okay, I will use a boolean number, a boolean value called is prime. Initially, I assume that the given number is prime, and then I check for all the values in the range 2 to num. If there exists any number which divides it leaving a remainder 0, I will set is prime to false only in that condition. So finally, if this variable is prime containing true, it means that it's a prime number. Otherwise, it's not a prime number. So for divisor in, what should be the range? Tell me what should be the range for checking. What
2
should I
and
write in range? 2 comma,
num.
what is the second value? Num. Okay, so it takes up the value starting from 2 up till n minus 1. It doesn't include num. Okay, now what should I write here? What is the condition? How do we test a condition? Which control structure should I use?
If
If. Okay, remember we have learned 3 control structures: if, okay, and variations of it. If else, if, yeah, if else. Okay, and 2 more control structures: the while and for loop. Okay, if is used for decision making, for and while is for repeated operations. Okay, performing repeated operations. Okay, now if, what is the condition? Tell me the condition.
num mod x is not equal to 0.
Num mod. Okay, I haven't used x.
Oh, sorry, divisor.
Okay, num mod divisor equal to 0. Okay, 1 minute. Tanmay, 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 don't go out of the stream unnecessarily. Okay, hello, Tanmay, are you there? Hello? Hello, Tanmay? Hello?
Yes, sir.
Hello? Tanmay, why you are quitting the session midway?
Sir, this laptop is not working properly. My mom called the technician today, so we'll fix it. It keeps restarting itself, sir.
Okay. Okay, fine. So if here in the condition, if num is divisible by divisor leaving a remainder 0, what does it indicate? Tanmay?
That it's coming.
Tanmay, 1 minute, Tanmay.
Sir,
Tanmay,
yes, sir.
if this condition is true, what does it indicate?
If it's
Okay,
true,
we have a number.
it indicates that it's
Ah,
not a prime number.
okay, right. So, what should I set is prime to in this case?
Uh, false.
Right. Okay, do that. Is prime is equal to false. Okay, next. After that, after this loop is over, if is prime is equal to true, okay, what should I do here? What is the action to be done? Can you guys tell? If is prime contains true, what does it indicate?
Uh,
What does
Num
it
is a
indicate? So the given number is a prime number. Okay, so just write that part. Print. Uh, okay, I will write that variable itself. Num comma is prime. Else part. What should I write in the else part?
num is not prime.
Num is not prime. Okay. Yeah. So let's see whether our program is correct or not. Control L. Okay, give. Tell me a number. Give me a sample number.
37.
37. Okay. 37 is a prime number. Okay. Give me example of a non-prime number. Some number.
25.
Okay, 25. 25 is not prime. Okay, so our program is working. Maybe for the case 2. Okay, fine. It's also working. Uh, okay. So if the given number is 2, then the range becomes 2 comma 2, where it will not iterate at all. Okay, is prime will remain true. It will not execute the body of the for, and it will say that 2 is prime. Okay, but here if I see, let's take the example of 6. Okay, number is 6. Okay, uh, in line number 13, what is the value of divisor? Initial value of divisor? Hello?
2.
Divisor has a value 2, num has a value 6. 6 modulo divisor. 6 modulo 2 is how much? If you divide 6
0.
by 2, what is the remainder? 0. So 0 is equal to 0. The condition is true. It sets it to false. Okay. Is prime is made false. After setting is prime to false, where will the control go? How will the execution continue? Will it go to line 17?
Mm,
Tanmay, what do you say?
Sir,
After setting is prime is equal to false,
yes, sir.
which instruction gets executed next? After line 15, where will the control go?
Line
The
17.
line 17, is it?
Uh, no, sir.
Line
It
13
goes,
is what
it
kind of
goes,
a
it goes
structure?
back to, yeah, for loop. It goes back to line
It's
13.
a for loop. Line 13, what will be the new value of divisor?
A new value of divisor would be the uh, number,
Which number?
given number.
No. What
No.
was the initial value of divisor?
Initial value of divisor was between 2 to uh,
Not
the
between,
number
it's a clear number, single number. You can't say between. Which value? First time when line number 13 is executed, what is the value of divisor?
2.
2. Okay. So 2 divide 6, leaving remainder 0, is prime is set to false. After this divisor is the iterator. It takes values in the range 2 to num. Okay, without including num. So after taking 2, which is the next value that it takes? Which is the next value in the range?
3.
3. Okay, it takes 3. Okay, again it checks whether 3 divides 6. Okay, in our case 6, the 3 divides 6, so again is prime is set to false. Next it takes the value 4. The condition is not true. 4 does not divide 6, leaving a remainder 0, so this statement is not executed. Again it takes the value 5. Okay, for this condition fails. Okay, 5 does not divide num, and when divisor becomes 6, okay, it moves out of the range, so for loop stops. What happened is is prime was set false uh, two times. Okay, when divisor was 2, it set is prime to false. When divisor was 3, again it was overwritten with false, which was not really required, right? So in real world, when you are checking in the range 2 to n minus 1, if you come across some number p, okay, which says that okay, it doesn't give a non-zero remainder, should I check for other values after p?
so could you repeat that again?
Like I am checking for a number n. Okay, listen clearly. I am checking whether a number n is prime or not. So what is the range of numbers that I am going to check for n?
From 2 to n.
2 to n, or 2 to correctly 2 to n minus 1. N is not included, right, in the range.
Yes, sir.
Okay,
Yes, sir.
mathematically. So we take every value from 2 in between 2 and n minus 1, including both of them, 2 and n minus 1, and I keep testing. So suppose in this range of values, let's say I have a value, let us call it p. Okay, p is a number in between 2 to n minus 1. So when I come to p, I find out that p divides n, leaving a remainder 0. Okay, so after that, do I go on to test p plus 1 also, whether it divides a n, leaving a remainder 0? Is it required?
No.
Like, for example, if n was our 6, okay, if we come to know that 2 itself divides 6, leaving a remainder 0, is it required for me to check whether 3 divides, 4 divides, 5 divides 6?
No, it's not required.
Not required, right? So even if there is one number that satisfies this condition, okay, then we can clearly know that it is not a prime number. So what happened in our program was it wastefully checked 3, 4, 5. Okay, suppose the input was 7, then checking from 2 up till 8 makes sense because none of the numbers divide it, leaving a remainder 0. In that case, it's okay to run through the whole range. But whenever a number divides the leaving a remainder 0, we don't need to proceed further. Okay, so in such scenarios we want the program not to compare further values, or in general when we are doing a repeated operation, if some particular condition is true, we would want to stop this repeated operations, we don't want to proceed. Okay, so for that we have a new control statement called as a break. Okay, so when we use the break statement, break can be placed either in a for loop or a while loop. Okay, let me show you an example. Like, did my text editor go? Yeah. So let's say we have a while loop while some condition execute statement 1, statement 2, if condition 2 break, then statement 3, statement 4, like that. Okay, same way I could also have a for loop also, for I in iterable. Okay, so we have introduced a new control statement called as the break. Okay, let's say, okay, even after the while loop we have some statements outside the while loop also, we have some statements, statement 6, whatever. So this could be pretty common in our in programs. We will see some examples of that also later. Okay, so let's first look into the while loop case. So whenever we are executing the body of the while loop, if the break statement is encountered, okay, so usually break statement should be written as part of a condition. It should be a conditional break. Okay, so what the break statement does is, if the break is encountered, it will skip the rest of the while loop. Okay, whatever body you have written after the while loop, okay, that will be skipped, and also it will terminate the loop. It will not go to the next iteration. Okay, that is how the break works. Suppose if you don't give a condition at all and you write break, then the while loop will only run once, executing only statement 1, statement 2. It would never execute statement 3, statement 4. Okay, so always break should be associated with a condition. Okay, so how will it work is, first it will check the while condition. If it is true, it will execute statement 1, statement 2, it will check the condition 2. If condition 2 is false, okay, this statement is skipped because it is part of the if. Break will not be executed. It goes on to statement 3, statement 4, and it will go to the next iteration. A while condition is tested again. It will execute, let's assume that it's true. It will re-execute statement 1, statement 2, condition 2, let's say it is false. So break is skipped. Statement 3, statement 4 is executed again. It goes to check the while condition. Let's say that is true again. Statement 1, statement 2 is executed. Next, let's say in the third iteration, the condition 2 is true. Okay, some particular condition that I have given is true. In that case, it will execute the body of if, which is the break. So when a break is encountered, it will not continue to execute the remaining statements. Statement 3, statement 4, these are skipped off. Okay, and it will not go to the next iteration of while also. It will come out of the while and go on to execute the next statements in the program. Then it will go to statement 5, statement 6, and so on. Okay, so did you understand how the break works? Hello?
Yes, sir.
Okay, if
Yes,
you have
sir.
any, do ask me, do ask me. Try to understand it carefully. So whenever we want to forcibly terminate a loop, okay, like I am doing a repeated task, but in some scenarios, if some particular condition is true, okay, I have to I have to stop the execution. Okay, like for example, I'm in an office. Okay, so the I will write a condition like till the time is not 6 p.m. keep on working. Okay, so that keep on working is repeated. Do the task is repeatedly done till the time is 6 p.m. Okay, but if there is a fire alarm in between, okay, in such case when there is a fire alarm, should I continue doing the work? Hello,
No.
what are we supposed to do? In case of a fire alarm, what would you do?
Run out.
You have to leave the place, right? Okay, so that is kind of an example. So in case of a fire alarm, don't continue your repeated task, don't continue your work, okay, which you are doing so far. Rather, come out of the building, something like that. Okay, so break is similar. You want a forcible termination of a loop, okay, be it a while loop or a for loop. Okay, so we use breaks for forcible termination. And when we do this forcible termination, do we do it always? No, only under certain conditions. That's why we write this break as part of some condition. Okay, only when that condition, special condition is satisfied, we break out of the loop. We come out of the loop. Okay, and and it will continue to execute the next part of the program. Break has the same behavior also within the for loop. Okay, it would be repeatedly executing as long as this condition is false. If this condition is true, then it would come out of the for loop and go on to execute the next lines in the program. Okay, so we just saw an example of this. Can you tell me now when we should break out in our program? When should we stop testing a number for primality?
So when the condition turns out to be true, if you want to eliminate.
Which condition? Which condition? In our program, which condition?
So if the remainder is 0, then we follow.
Zero. Yeah, this condition. Okay, line number 14. Okay, see, We have a for loop. We have a condition also here. If this condition is true, two actions need to be taken. One is set set the prime variable to false. Okay, is prime variable to false, and also we will use a break. Okay, so break, I have written it at one tab, so it means that it is part of the if statement. Okay, so what I will do is just for you to understand, print divisor. Every time I will print divisor also. Okay, let's say that this break is not there. Let's see what the program does. Um, Run, enter a number 9. Okay, so the range is checked 2 to 8. Okay, I'm printing the divisor. Divisor can go up, start from 2 up till 8. Okay, and this is the 9 is not part of that sequence. It is just coming from here. 9 is prime or 9 is not prime. Okay, so for a prime number, checking all these values makes sense. 2, 3, 4, 5, 6, 7, 8. Okay, however, for a non-prime number, that is not the case. Let me rerun the program again. Okay, let's say 8. For 8, our supposed range is to check from 2 to 7. Okay, so in the absence of break, we are checking from 2 to 7 and then saying 8 is not prime. Okay, but when we divided it by 2 itself, 8 was divisible, so there was no point in checking for 3, 4, 5, 6, 7. So to prevent this, okay, to make a run program much more faster, do lesser number of instructions. In this case, at any point, if I find that the divisor is dividing the given number, leaving a remainder 0, then we have to stop the loop. Okay, terminate the loop. So let's rerun the program. Let's enter 9. Okay, 9 is not prime because we found out a number 3 which was dividing 9. That's why we didn't go further 4, 5, 6, 7, 8 like earlier. See it, even after checking with 3, it went on to check with 4, 5, 6, 7, 8, and then it said 9 is not prime. Okay, which was not required. Now it is doing lesser number of operations. Okay, this is how we make use of a break statement. Okay, now write a program to display first n prime numbers, where n is given as input. Okay, so now suppose the input were to be 4. What is the output of the program? If n is 4, what should be the output of the program?
2 and 3.
No, read the question. Can you read it out again? Disha, read the question again.
Write a program to display first n prime numbers where n is given as
Yeah.
input.
So I said first n prime numbers, not first n numbers. To check within n numbers. Okay. So if my input is 4, I have to display the first 4 prime numbers. 2 and 3 are only 2. So what should your program print actually? 2, 3, next
5, 7.
5, 7. Okay, it has to print the first n prime numbers. 2, 3, 5, 7. If n is 4, it should print 2, 3, 5, 7. If n is 5, it should print 2, 3, 5, 7, 11. Okay, and so on. So the idea here is, okay, I start with the value 2, okay, and I check whether the number is prime. Okay, if it is prime, only then I will display it onto the screen. Then I will check for the next number. Okay, and also whenever I get a prime number, what else I should do? I will also, apart from displaying it onto the screen, I will keep track of the count also, because my program should show me only first n prime numbers. Okay, so after displaying the first prime number, my count should be 1. Then I go to the next number, check whether it is prime or not. If it is not prime, I go to the next number. If it is prime, I display it, I update my count. Okay, so I should keep repeating this till I have found out first n prime numbers. Okay, so try to write the program for this. I have given you the idea. Okay, n prime dot py. We'll take the input.
So you're not presenting the screen.
Okay, okay. Yeah, okay. We will read a number, enter the number of primes to be generated in this case, right? Primes to be generated. Enter the number of primes to be generated after this. Okay. Now tell me, what should we do next after reading the input? How many times should we repeatedly check for a prime number? Hmm?
Till we reach n plus 1, like num plus 1,
Num plus 1.
like in the range. So it'll
No,
be
don't I? No, no, no. Don't I require? See, the boundary when I say if n is 4, it doesn't stop at 5. Does it stop at 5? Checking from 2 to 5?
like
So from where will the value start?
I'll
If I
start.
ask you to print, huh? It will
Sorry,
start
sir.
from.
Continue.
So if I'm looking for first n primes, let's say n is 4, okay? So which is the first value that I have to consider for checking whether it is prime or not? From where should I begin?
One.
Huh?
One.
One is neither prime nor composite, so I
Two,
should not start with 1. Okay, I should
two.
start with the value being 2. Okay, I will start from 2 and then keep on checking. Okay, I will check 2 whether it is prime. Okay, if it is prime I will display it, and then I go to 3. If it is prime I display it like that. Okay, at the same time, till I have encountered n such prime numbers. Okay, so how do we keep track of that? We require another variable. Okay, count. What is the initial value of count? Initially we haven't found out anything, so we say that uh, so far I have encountered 0 prime numbers. Okay, this is the initial setting. Start from value. Okay, value 2, and we should set the count as 0. Now what is the condition here? What should be the condition for the while loop? Hmm? When we should stop checking for prime numbers?
When count is equal to 4.
In general, in our program, you are right. In our program, what should it be? Will it be 4 always?
Count is equal to num.
While count not equal to num, I should keep checking. Okay, when count equals to num, it should stop. Okay, or count less than or equal to. Okay, count less than num. Okay, equal to also, as long as the count is less, keep finding. Okay, when it becomes equal to num, we stop. Count. Yeah. Okay. Now, now, which entity should be checked whether it is prime or not? Which variable should I consider for primarity testing? Why do we have the variable value?
Yeah, we check
We should
value.
check whether value is prime or not. So, like as we did earlier, we will say is prime is equal to true. To begin with, we say that okay, it's a prime number. So for I in range value, okay, 2 comma value, 2 comma value. This is the same code as the previous. Okay, if value is divisible by I, leaving a remainder 0, is prime is equal to false. Okay, and break out of the loop. After that, if is prime is equal to true, if is prime is equal to true, then which value should I print? What should I print here?
Value.
value. Okay, because value is being tested whether it is prime or not. If is prime remains true, then only I display value. Okay, so I don't require a else part. If it is not prime, I am not going to display it. Okay, after that, whenever we have encountered a prime number, apart from displaying the value, what is the other action you take?
Value is equal to value plus 1 and count is equal to count plus 1.
So we increase the count. First thing, because we have encountered the prime number, we will increase it by one. Okay, only when we have found out a prime number. Okay. However, changing the value, uh, should it be done only when it is a prime number or otherwise also?
Otherwise as well.
Otherwise as well. Okay, so it is not dependent on whether the number was prime or not. Okay, say I was checking for let's say 4. Okay, 4 turns out that it's not a prime number. It doesn't mean that I have to stop there. Okay, it has to be incremented whether it's a prime number or not, because we have to go to the next number. So we check with value. So value is not written inside the if block. Okay, just for readability, I'm adding empty lines. Okay, value is equal to value plus 1. Okay, so let's try to run this. Let's see whether our program is giving the intended output. Okay, 4 if we give, okay, let me give a space here. So prime numbers to be generated, if I give 7, 2, 3, 5, 7, 11, 13, 17. Okay, so we are getting our proper values. Let's see, okay, how this program is executing. Let's do the stepwise execution so that you understand it better. So the idea is to start with debug. Okay, we are running it in debug mode. Enter the prime numbers. Let's say 4. 4 is the input. Okay, let's look at the variables created. Num contains a value 4. Okay, after this, the variable value is created with the value 2. Count is created with the value 2. Sorry, 0. Okay, so we have to generate 4 prime numbers, and we start with the number 2 to check whether it is prime or not. From 2 onwards, we keep checking forward in the forward direction. So count is less than num. Count is 0, num is 4. So 0 is less than num. Condition is true. So it will go to the next line. Okay. Initially, for every number, I assume that it is a prime number and then I try to falsify it. Okay. If there is a number in the range 2 to n minus 1 which divides the number n, in such case, we set is prime to false. Otherwise, it would remain true itself. Okay. So for 2, I have set is prime to be true. Next, for I in range 2 comma value. So what happens here is, okay, value is also 2. So the for loop will not execute. Okay. It will go to the if statement. Let's see. Did you see? Range of 2 comma 2 doesn't give us anything. Okay, so it's an empty sequence, so the for loop will not run even once. It next goes on to check the condition. Prime was set to true, so this condition is also true. We print the value. Okay, see, 2 gets printed onto the screen. Next, now that we have found out one prime number, we are increasing the count. Okay, so count also became 1 now, which was earlier 0, count became 1. Okay, now we have finished testing with 2. We have to go to test the next number, for which we have to increase the value of value by 1. So next statement, value becomes 3. Now again we check whether count is less than num. Yes, 1 is less than 4. Okay. So now value contains 3. We assume 3 as a prime number to begin with. Okay. And then we check whether it is a prime number or not using this for loop. Okay. 2 comma 3. So for I in range, 2 comma value is 3. Okay. So value has a variable 3. So this loop will run once. I will take up the value 2. Okay. If you see here, I has a value 2 here, starting value. So next, the condition is value 3. 3 mod I. 3 mod 2, is it 0? The condition is false. So this if statement failed. Then I is trying to go to the next run where I becomes 3 and it goes out of range. So this for loop finishes execution. It goes to the next statement, which is the conditional check. Is prime is equal to true. Condition is true. Okay, 3 is a prime number. We print 3, and because 3 is a prime number, we have just encountered another prime number. We are increasing the count by 1. So count became 2 here. Then next value that I have to check is 4. Okay, so I check for 4. Count is still less than num. 2 is less than 4. Okay, for 4 I initially assume that it is a prime number. Then for I in range 2 comma 4, I takes up the value 2. Okay, I has a value 2. Does 4 divide 2 leaving a remainder 0? The condition is true. Okay, so is prime is set to false. And next we encounter a break. So because of the break, control comes out of the for loop. Okay, we check whether is prime is equal to true. No, is prime has been set to false. So this condition also is not the body is not executed. These two statements is not executed. Count will remain 2 itself. Okay, so it is skipped off, but we increment value by 1 so that we go to the next value, which is 5. Okay, value becomes 5, and like that repeated operations you can find that. See, for 5 it displays the number and it increases the count becomes 3. Next, 3 is less than 4. Okay, so for 6 it is setting is prime to true. Here the condition is true. 6 mod 2 is 0, so is prime will be set to false, and we break out of the loop. Okay, because is prime is not equal to true, even this is skipped off. Okay, so 6 is not going to be printed, count is not going to be incremented. Okay, value, the 6 gets incremented to 7, value becomes 7. Count is still 3, which is less than num, which is 4. So again we enter. Okay, we say 7's is prime is true. Okay, and then this for loop we run for I is equal to 2, I is equal to 3, I is equal to 4, I is equal to 5, I is equal to 6. Okay, and now it comes out of the for loop. Okay, none of the cases this condition was true. So is prime was never set to false. Is prime, you can see, is still true. So this condition is true now. It prints value, which is 7. Okay, the value 7 gets printed, and then we increase the count to count by 1. So count becomes 4. You see, count is now 4. We increase the value by 1. Next value to be considered is 8. Okay, but however the while loop will fail. Okay, count also has a value 4, num also has a value 4. So we see that while loop failed. Okay, and we can see the return statement here. Okay, the program has finished execution. After the while statement, there was nothing else. Okay, so the program terminated. So this is how we make use of the break statement in our programs. Okay, whenever another thing, if you observe here, the break statement came only out of the inner for, not out of the outer while. Okay, so whenever a break is placed in a nested loop, it will always come out of the inner loop that it is placed in, not of the outer loop. Okay, if a break has been written with a condition at a single tab, then it becomes part of the outer while. Okay, this is another thing that you have to observe. So if I give 5, it generates the first prime number, 5 prime numbers, 2, 3, 5, 7, 11. Okay. Another controls like this, whenever required, we if we want to forcibly terminate a particular loop, we make use of the break statement. Okay. Yeah, fine. Nested loop. Okay. Yeah. Other than break, we have one more control structure. So break control structure. It is used for forcible loop termination. Okay, it should be associated always with the condition. Next, we have another one. For example, there is the fourth control structure called as the continue control structure. Like how we have break, we also have continue. Okay. Where did I write that break thing? Okay. Yeah. This. Let's take the same examples. Okay. So for continue, we will use the keyword continue. Okay. Instead of break, let's say I am using continue in my program. Let's try to understand what's the behavior of it. Okay. We saw earlier, whenever there was a break, it comes out of the for, goes on to execute the next statements. Okay. But in some cases, you would want to keep on perform a repeated task. Okay. But when some particular condition is satisfied, okay, you don't want to execute the rest of the body of the loop, rather you want to go to the next iteration. Okay, so in such cases we make use of the continue statement. So if a continue is placed in a while loop of this form, okay, while condition, let's assume it is true, so it will execute statement 1, statement 2. If condition 2 is false, continue is not executed, it will execute statement 3, statement 4, and so on. Okay, after that it will again go back, check the condition, so it keeps on executing this repeatedly. Suppose at some point, if condition 2 is true, then we have a statement called as continue. Okay, so in case of break, what used to happen is it would break out of the while loop, it would come out of the while loop, go on to the next statement, statement 5. But however, in case of continue, what it does is it will not break out of the loop. Okay, rather it will send the control to the beginning of the loop again, skipping the remainder of the loop. Statement 3, statement 4 will not be executed. In that case, it will go back to the beginning of the while loop. Again, the condition is tested. It will execute statement 1, statement 2. If condition is false, continue skipped, it will execute statement 3, statement 4, it will go back. Okay. Suppose at a later time, again, if condition 2 is true, it will execute only statement 1, statement 2, and statement 3, statement 4 are skipped off. Okay. So, continue is typically useful when you don't want a part of the loop not to be executed in a specific case. In such cases, we make use of continue. Okay. For example, let's say that you are supposed to display all the numbers in the range 1 to 100 which are not multiples of 5. Okay. So, can you tell me how you can use continue here? What is the expected output of this 1 to 100? Which are the numbers that are not multiples of 5?
1, 2,
Hello?
3, 4,
4.
6,
Then should
7.
we include 5? 5 will
No.
not be included. Okay. 5 should be skipped off. Okay. 6, 7, 8, 9, 10 should be skipped. So in such cases, when we encounter, so what I have to do is I have to simply write a for loop to print from 1 to 100. But for numbers that are multiple of 5, okay, it should skip off the print operation, something like that. So let's write that program. Okay, I will show that here. Control N, Control F, Control S. Continue. Let me call this program as continue demo.py. Save. Okay. Uh, let's say I is equal to 1 while I is less than or equal to 100. Okay. I use the continue is equal to 0. Okay. I plus is equal to 1. Okay. If I mod phi is equal to 0, I would say continue. Otherwise, print I, comma, end is equal to, I will not print it in separate lines. I will print it in a print it by using tabs in between slash t. Oh, there is a space here. Okay. Okay. Type this program along with me. Finish
Here,
it. Yeah.
it's
Disha,
easy to use for loop instead of while.
I can. Okay. I'm just showing an example of continue within while. Next, I will show you the for also. Both. I
Okay.
will show you both. How to use continue within while and continue within for, something like that. Okay, let's run the program. Okay, you can see the output 1, 2, 3, 4, 5 is not there, 6, 7, 8, 9, 10 is not there, 11, 12, 13, 14, and so on. Okay, so what happened here? We start with I is equal to 0. As long as I is less than or equal to 100, we increase I by 1, and if it is a multiple of 5, okay, continuous statement will be executed. So the print statement will not be executed in that case if the condition is true. But in our case, I value is 1. 1 mod 5 is not equal to 0. So continue is not executed. It will print 1. Okay. Next, I is next it will go check whether 1 is less than or 100. Yes, the condition is true. And I think I should just use I less than 100. Okay. Otherwise, it prints 101 also. Okay. Let's rerun the program. Yeah, 99. Okay. As long as I is less than 100. So in this case, next I becomes 2. 2 also is not a multiple of 5. Okay. So it gets printed 3, 4. When I becomes 5. Okay. After 4, I becomes, when I increase it by 1, I becomes 5. 5 mod 5 gives me 0. In which case, the continuous statement is executed. Let's see that once. Let's use the debug mode. Okay. So I is set to 0. Next, condition is true. 0 is less than 100. I is incremented by 1. I becomes 1. 1 mod 5 is equal to 0 is false. So continue is not executed. It prints. Okay. It prints 1. It prints 2, 3, 4. Okay. See, after now I becomes 5. Okay. So when we encounter continue, okay, 5 mod 5 is 0. So it enters the body of if where there is a continue statement. What this continue does is whatever is in the body of the while loop after the continue, all that part is skipped off. Okay. And as a reason, I being 5 is not printed onto the screen. It will take to the beginning. Okay. Next iteration of the while loop. Okay. It takes the control to the beginning of the while loop and it continues. Okay. I becomes 6 now. 6 now after line number 11. 6 mod 5. It is not a multiple of 0. So continue is not executed. It will print 6. Okay. And so on. So did you understand the continue statements? Any doubts? If you have any doubts, do ask me. Feel free to ask. Hello?
No, sir.
No, sir.
Yeah. Okay. So let's rewrite the same thing using a for loop as well. Let me comment this out. For I in range, okay, for I in range 100, because I don't have a increment operation required, it is automatically done. Okay, I takes different values. I will simply write some extra additional instructions like I will copy it into I and then display it. Okay, num is equal to I. If num mod 5 is equal to 0, then continue. Okay, don't display it. Otherwise, print num comma end is equal to /t. Okay, so you may ask, I could have straight away written I mod 5, Just for you to illustrate that, it would execute instructions before the continue statements and skip part of it afterwards. I have just written in this form. Okay, you can avoid in your code, you can avoid line number 17 and directly write I mod 5 also. That's also okay, and print I. So num is just a copy of I. So in this case as well, as you can see, the output would be the same. 1, 2, 3, 4, 5 is skipped off, 6, 7, 8, 9, 10 is skipped off, and so on. Okay. Any doubts in this part in the for loop?
No, sir.
Okay. Clear, right? In this case. So what you have to so to summarize, whenever you want to forcibly terminate a loop, which control structure are you going to use?
Break.
Break. Okay, so when you want to skip portion of the loop, okay, what should we use?
Continue.
Continue. Okay, so another thing that you have to understand is, whenever we encounter a break, suppose if there was a break statement as we have shown here. Okay, so whenever there is a break, control comes out of the loop. Okay, the loop is terminated. Whenever there is a continue in our program, okay, it doesn't come out of the loop, rather it goes to the beginning of the loop. That's all the statements after it are going to be ignored. Okay, like break, continue also should be associated with a condition. This is how we make use of the continue statements. So totally uh, so this is with regard to the control structures provided in Python. Okay, so what did we learn? First we learned the if statement. Okay, under if, the simplest form of it was the if followed by a condition. Okay, or you can write a if else condition where you can perform a two-way condition. And then we have the if else if ladder, which allows you to choose between multiple options. Okay, so this is one of the type of control structures that we call as the selection or decision making control structures. Later we looked into looping or the repetition control structures. Which are the looping and repetition control structures? Hello, answer me, Disha.
While
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 and
and for loop.
while and the for
For
loop. Okay, for loops. So that those we discussed. So whenever we don't know how many times a loop has to execute, but we clearly know that it has to execute as long as some condition is true, we make use of the while loop. Okay. In cases where we clearly know the number of times a loop runs, we make use of the for loop. Okay. And in all these control structures, okay, we saw nesting. We can place a if statement within another if statement. We can write a loop within another loop. For example, while within a while, for within a for, or while within a for within a while. All this is possible. Apart from decision making and looping control, we have the third type called as the jump control or the jump statements. Okay, so Python provides two jump statements. They are break and continue. Okay, why we call them jump control is because from one line in the program, they transfer the control to some other line in the program. That's the reason we call them jump control structures. Okay, so break usually transfers the control to the end of the loop. Okay, terminating the loop, whereas continue transfers the continuation transfers the control to the beginning of the loop, going to the next iteration, skipping any statements after it. Okay, so that is with regard to the control structures. So we have totally if, while, for, break, and continue. These are the control structures that are available in Python. Okay. Next, we will finish off loops yeah, by having a look at the Turtle library. Okay. Earlier we had written simple programs using the Turtle library. In today's class, we will see much more different examples of the Turtle library. Okay. Okay. Write this program. You can copy paste repeated things. Don't need to type it again and again. Finished?
Almost, sir.
Okay, only write this part. Okay, not the commented ones. If you have finished typing, just execute the program and see the output as well.
Done, sir.
Okay. So let's run the program. See, the turtle moved forward by 100. It turned left by 120 degrees, waited for 5 seconds, again draw 50, it turned by 120, waited 5 seconds, turned by 120 degrees, and then it has stopped. Okay. So you can write instructions as just import turtle, but every time you have to write turtle.forward, turtle.left. Rather, to make it simpler, I have said turtle as t. Okay. Import the turtle package and rename it as t. So I don't need to write turtle dot. Rather, I can just write t dot forward and so on. Okay. Let me show that in a shell. Import turtle as t dot forward 100. Okay. So you see that the turtle has moved forward by 100 positions. Instead of forward, we can also use, where is that? I did save it. Nested loop control such multiplication. Yeah, okay. We can also use FD. Okay, so let's see that. You can also type in your program is instead of forward, you can also write T dot FD of 50. Okay, let me show that to you. Okay, so FD and forward both have the same meaning. Okay, so you can decide whether to use forward or FD. Okay, like that, you can also use T dot backward. Let's say backward by 200 positions. Okay, it has moved forward by 150 positions from the center. Now if this is executed, it will move back by 200 positions. Okay, and while moving back also it draws a line, but because it is on the same line, it appears there is just only a single line. Okay, T dot backward, or you could use T dot BK 50. Okay, so the turtle moves further backward, or there is another called back also. Okay, T dot back 30, let's say. So forward FD have the same meaning, backward BK back all have the same meaning. Did you try out these functions? You can type them from your Python console also here. Okay, here also you can give those commands. Now to terminate our turtle program, we have to give an instruction called as t.done. Okay, then only your turtle program will be properly terminated. Otherwise, you may get errors. Okay, so in this example, what we have done is we have drawn a equilateral triangle. So every time the turtle is turning by 120 degrees to the left. Okay, and because of it, see, when the turtle draws, it would be facing in the east direction. Okay, so even though the inner angle of the triangle is 60-degree, okay, because it was facing east, I have to make it rotate by 120 degrees to the left. Okay, did you understand why we have given 120 degrees, not 60-degree?
Yes, sir.
See what happens if we give 60-degree. Make the change to 60-degree and see the result. Change 120 to 60-degree everywhere. Sixty. Okay, so it doesn't give us a triangle. Okay, because from here it is turning only by 60 degrees. From this axis it has turned only 60 degrees, and so on. So for getting a closed triangle, we should rotate it by 120 degrees. Okay. So let's.
So what happens when you change 120 to 60? My Python is not working
Okay, I will
properly.
show you. I will show you. Where did I close that output? See here. Okay, instead of turning by 120 to the left, it turned only 60 degrees. Are you able to see?
Yes, sir.
Okay, and it stops. It is just drawing only three lines. So if I were supposed to draw a hexagon, this would make sense. Okay,
Yes, sir.
so if I just copy the whole code and paste it again, okay, I will instead get a hexagon this time. Fine. Okay, got it.
Yes, sir.
So this sleep is not really required. Okay, I have only after drawing a line and turning by 60 degrees, I am saying suspend for 5 seconds. It is optional. Okay, so you need not really use the sleeps. If you require, you can. So I will remove that and run the program. So now there is no delay. Okay, it immediately draws the graphic. Okay, fine. Okay. Next, we have a pause method. Pause method gives us the position of the turtle, okay, as a coordinate value. Okay, two coordinate value. It will tell you x coordinate and y coordinate. Okay, let's see that. T dot done should be, see, T dot done should always be the last instruction in your program. T dot done. Okay, I will remove this. Here I will comment it. I will remove it. Commenting is as good as removing it. Okay, so I want to know what is the current position of the turtle now. So for which I have given t dot pause, print t dot pause. In your program output window, it has given us the value that it is at position 100 and 173. Okay, x coordinate is 100, y coordinate is 173.21. So this is how you obtain the current turtle position. Okay. Then we have another function called as t dot. I think instead of t dot pause, you can use t dot position also. Yeah, position and pause have the same meaning. Okay, so pause or position should also work. T dot pause. I will write it as a comment here. T dot position also gives same effect. Okay. Next, let's see t dot home. Okay, if you want to make the turtle move back to the origin, okay, to the place where it started, uh, and also let's print the position as well. Okay, let's run the program. So previous program output you have to close, otherwise the program won't run. Okay, so what will t.home do? Can someone tell me?
So
Hello.
Tushar's not there, and can you repeat your question?
Uh, yeah. T.home. What would t.home do? Was my question.
Uh,
From wherever the
It go to
turtle
its
is, turtle
return to
is
its original position.
return to 0 0. Okay. So see, at this position I printed the coordinates. It gives me 100 173. After coming to home also, when I'm printing the coordinates, what do you see? 0 0. Okay. So home will always return back the turtle back to the original position 0 0. Okay. Then let's say you want to clear the screen, then we use clear turtle clear screen. Okay. Oh, I should use it earlier. Okay. For 5 seconds afterwards, clear the screen, and let's say e dot circle uh, with radius 10 or 20. Okay. So let's see two more new methods, clear screen and circle. So let's rerun the program. Okay, it draws this for 5 seconds, it waits. And what did you observe after coming back to home? What did you observe here? What did line number 35 do? Hello? Hello?
Yes, sir. Could you just repeat
Yes,
again?
sir.
Have some network issue.
Okay, let me run the program again. So what I did was, after it came back to home, I have given it a delay of 5 seconds. I have made it to wait for 5 seconds. Then I have ran these two instructions, clear screen and circle. Okay, so let's run the program. Look at the output of the program. Now tell me what happened after t.home. What happened? What did clear screen do?
Yes, sir. So
Hmm?
after clear screen, um,
Huh. The
waited
previous contents were
after
erased.
waited. Yes, sir.
Yeah. So your entire screen is erased. You get a fresh screen, and later whatever I draw, it will display onto the screen. Okay. So t dot circle. There is a method called circle. If you want to draw a circle with radius 20, you should say t dot circle of 20. Okay. Then we have something called as do we have that later example? Pen up, pen down. Okay, yeah, I think I have them here. Control C. Okay, so previous things, I will comment it out. We have already learned the behavior. We don't want them. Okay. We learned about home, sleep, all this clear screen and all. Okay, we'll not. We will look at two more methods, pen up and pen down, and go to. Okay, third. Okay, we are illustrating three new things. Okay, first let's see the program output so that you will understand. Okay, let me close this. Okay, let's see here. First, it draws a circle of radius 20. Okay, and let's say that we didn't have this pen up pen down thing. Control 1. Let's say I comment it out. Let's see the behavior. So I'm saying t dot circle, draw a circle with radius 20. Go to method, it's quite obvious. What does the go to method do?
Go to
Hmm?
we'll go to the position which you mentioned.
Yeah, which is specified as the coordinate here. From the after drawing the circle, okay, it was at this particular position. From here, I'm saying go to location 100. Okay, and so it goes to that particular location, drawing a line as well. Okay, and then at this position, it has drawn a circle with 50 radius of 50. That's why this is much larger than the first circle. Okay, if I don't want this particular circle, sorry, this joining line, I want two separate circles. What I can do is I can say pen up. Okay, you can imagine like the turtle, yeah, when it is drawing, it has put the pen down and it is moving, and that's why it is drawing a line. Pen up will make the turtle take the pen up. Okay, it will just move but not draw a line. And later, if you want it, for further contents to be drawn, you can do pen down also. Let's see once without using pen down. Okay. What did you observe while drawing the second circle?
It's not visible.
The reason was because the pen was up. Okay, it draws a circle keeping the pen up, and hence no line was drawn there. Okay, and even while doing the go to also, the pen up was already. So once you execute pen up, until you call the pen down, okay, the pen will remain up. Okay, so what it did here was draw a circle here, go to the 100, draw another circle. Okay, so because pen up was used, the go to function didn't draw a line, it just simply moved. Okay, so if you want, after executing the go to, if you want it to draw the line again, you have to make the pen down by calling the pen down function t dot pen down. Okay, so now let's rerun the program. Draw circle of 50, go to 100, and then draw a circle of 50 again. Okay, circle can take two parameters also. Let me give a parameter as 120. Okay, extend. Yeah, okay. So the second parameter in circle is called as the extent. How much portion of the circle you want it drawn. So that the maximum value is 360 where it draws an entire circle. Okay. I gave 120, I got only one third of the circle. Okay. If I have to draw half the circle, what should I give? Hello?
Yes, sir.
If I were supposed to draw only half the circle, what value should I give here?
60.
No, not half of this. In the entire
Oh,
circle, okay, I want only half.
180.
180. Okay, because 360 is full. Okay, 360 degree is full. So if I give 180 degree, then it will draw half the circle. Okay, so circle can be used to draw arcs of a particular radius. Okay, so now this is an arc of a radius 50 and of angle 180 degree. Okay, so did you understand the meaning of circle? What is the first parameter in circle? What does it represent?
X.
50 here is
X,
what? Huh?
X
Yes?
position.
No, it's not exposition.
Sorry, sir. I
Position
was.
is here, 100. We have specified the position. Okay, at 100, it is drawing a circle. Again, 100 is not the center of the circle. Okay, initial position of the turtle. First parameter yeah, is always the radius. Okay, t dot circle 20 means draw a circle of radius 20. T dot circle 50 means draw a circle of radius 50. If you give an additional parameter, second parameter, then it is called as the extent. Okay, to what extent you want to draw the circle? I want the circle to draw for 180 degrees. Okay, so it has drawn for 180 degrees. Got this? Any
Yes, sir.
queries? Any queries in this?
No, sir.
Okay, shall we go move to the next things? Uh, okay, left, forward, home, we discussed, sleep, all this. Okay, so we can even use loops along with uh, Python code, turtle code. Let's see that. Okay, the same triangle, I can write it using a for loop or a while loop. Okay, write this code. Does this code print you a triangle? Finished?
Yes, sir.
Hello? Okay. So in this case, instead of repeatedly writing it multiple times, I can write it in a loop. Okay. So every time turn by 120 degree and move 100 steps forward. Okay. So how many times will the loop run in this case?
Thrice.
Thrice. 0, 1, 2. Okay, range 3 gives me 0, 1, 2. So I is equal to 0. Once it will run, I is equal to 1. Another time, I is equal to 2. So 3 times it will run. So 3 times it will turn by 120 and move by 100. Turn by 120, move by 100. Therefore, we get a triangle. Okay. So like that, you can write it in while loop also. Okay, I have shown a for. Obviously, you could be able to write it in for as well. Okay, write the next lines. Okay, change. Just copy paste your for loop. Okay. So instead of left, you can also use right also. Okay, it turns in the opposite direction. That's all. Write this code. So when I turn by 120 degrees, the inner angle will be 60 degrees. What will be the inner angle in this case? For I in range 18, repeat this 18 times. Tell me why I have chosen the value 18 here.
It can draw 18 lines.
Huh? Run the program and look at like why I gave 3 earlier. Okay, how 3 is related to 120. In the same way, think of how 18 could be related to 170. What is the output? Did you see the output of the program?
Sir, my Python is still loading. It's, I don't know, it's loading.
Can you see the output on my screen?
Yes, sir.
Huh?
Yes, sir.
It should have run. Okay, one more time, I guess. Let me come to that. Okay, it's still not complete. Okay, I guess this should be. So, if you look at the output of the program, if you look carefully, okay, when we will say that it has drawn the proper pattern is when it comes back to the same position at which it started. Okay, but that is not happening here. Okay, that's why we are not getting a complete pattern. So, because we don't know how many times to repeat, okay, what I have done is instead of using a for loop, I have used a slightly different loop. Okay, Let me use 170 itself. Are you able to see the pattern now? Hello?
Yes, sir.
Yeah. So what happened is the pattern is complete when after drawing the last line, it has arrived at the original position. Okay, I should not use this t dot height turtle, otherwise it's not showing the. Okay, look carefully at the point where it begins, and you see that it should end exactly at the same point. Okay, I am keeping my cursor here at the point where it began. So the program should stop exactly at that same point. Okay, can you see that the cursor has stopped there?
Sir?
Hello, can you see that? Can you see the turtle black color arrow and my mouse pointer, both of them?
Yes, sir.
Okay, so I don't know as to how many number of times the loop is supposed to run. So in which case I use a while loop. Okay, Disha, can you hear me now?
Yes, sir.
Yeah, okay. So whenever I am not sure as to how many times a loop has to run, okay, in such case, I will say run this loop infinitely. Okay, how do I run an infinite loop? I will give the condition as true. Okay, so because this condition is always true, it will keep repeating the while loop. But however, my program cannot run infinitely. Okay, so to stop this infinite loop, I place a condition. Okay, you see break is there with a condition. So the initial position was 0 0. Okay, so if I compute the absolute, okay, absolute of a Cartesian value is square root of a square plus b square. So 0 plus 0 square plus 0 square whole square root is 0, which is less than 1. Okay, so this is how we can test whether it has returned back to its original position. So if the turtle has so every time after turning right by 170 and drawing the line by 100 positions, I check whether the current position is 0 0 by using this t dot pos and calculating the absolute of it. Okay, if it is lesser than 1, okay, or 0, then I say that okay, we have arrived at the initial point, so we stop there. Okay, so then after displaying the pattern, if I okay, if I don't want this turtle to be visible, okay, here the turtle is visible, you can hide the turtle by using t dot hide turtle. Okay, I think there is t dot yeah, hide turtle, correct. So if I use hide t dot hide turtle, then after the while loop is over, the turtle will be hidden. You can see only the pattern. Okay. Let's see what happens if we run this code. So the turtle is hidden, but wherever it is moving, a line is being drawn. Okay, so did you understand height turtle method? Hello?
Yes, sir.
Yes, sir.
Okay. I think it's time now. Remaining methods in turtle graphics we will discuss in the next session. Okay. So uh, we will have it on 5th, right? Not Sunday. Saturday is fine or Sunday is fine?
Sir, Saturday I think I have a online session from my school.
Okay. So then, okay, we will have it on Sunday then. Okay. So I think Sunday will be,
Oh no, sir, it's tomorrow. So Saturday
huh?
is fine. Saturday is fine, sir.
Saturday is fine.
Yes, sir.
Okay. So we will have two more sessions, I guess. Okay. After that, we will be breaking for like 10 or 12 days. Okay. So maybe, but another session we will have on 5th. Then possibly 7th or 8th. I think 7th only. Only for the next week we will do it on 7th, 5 and 7. Okay.
Sir, I don't think I'll attend on 7th because I have
You
test
have an
started.
exam.
Yes, sir.
Okay then. So we will stop next Saturday itself then. Okay. We'll do a session on Saturday and we will break. After probably we will have the next session on 17th or 19th sometime later. I will decide that. Okay. So do attend Saturday session. Saturday is final. Disha, is it fine with you?
Yes, sir.
Yeah. Okay. Okay then. Okay. So we'll stop here.